Alright, so today we're going to take a look at point-slope form for writing equations of lines. Most people come into this class thinking about or being familiar with y equals mx plus b, or slope-intercept form, where m is going to be your slope and b is going to be your y-intercept. Now, this is taught in earlier classes in Algebra 1 and stuff like that because it's easy to do. Easy to graph, that is. It's easy for substitutions. You can use your calculator to graph things. But as we advance in our algebraic work, it becomes more apparent that there are better, faster ways to go about doing this. Now, what I mean by that is if you're given something, if you're given the characteristics that you're trying to find, or so you have a line that has a slope and a given y-intercept, yeah, slope-intercept's super fast to go ahead and do. But if you're not given that y-intercept and instead you have to find it, it could potentially be a lengthy process, right? So this is where point slope comes in. Now, point slope form looks like this, where it's y minus y1 equals m times x minus x1. Now, a lot of people don't like this formula because there's a lot of pieces to it, or at least there seems to be. But if we think about what those pieces actually are, the left-hand side, the m, and the other set of parentheses, it's actually something familiar to everybody. So let's take a break from that for a second. Let's take a look at just slope in general. Right? When we introduce the idea of slope, we're thinking about rise over run, change in y over change in x, right? We also have the formula for slope where it's going to be y2 minus y1 over x2 minus x1 for a given pair of coordinates, or pair of points here, x1, y1, and x2, y2. So here I'm just going to find the formula, just plug those things in, make it work. Right? So nobody really hesitates with the slope formula. That's an easy formula that you learn early on in algebra. But if we take a look at that formula, and if I look at this thing in a little more detail here, think about this. What would happen if I multiplied both sides of the equation by the denominator? Right? x2 minus x1, I'll put parentheses around that too. But whatever I do to one side, I need to do to the other side to balance out the equation. Right? The right-hand side, the denominator cancels with that new factor there. And I'm left with this. x2 minus x1, that quantity on the right-hand side multiplied by m, equals to y2 minus y1. Right? Hopefully you're seeing something a little bit familiar with what we see on the right-hand side in point-slope form. Right? It's a little bit different because I have more subscripts, but here if I look at this thing, I can kind of rearrange it. Remember, we have the equation can be written, flipped around. I could rewrite it like this, y2 minus y1 equals m. And multiplication is commutative, so I could switch around the m in that set of parentheses, right? But this is different because I have that y2 and x2. But remember, this is just a pair of coordinates, right? If we're doing point-slope form, as the name suggests, all we need is a single point, so one pair of coordinates, and a slope, right? So this is point-slope form, right? And point-slope form is actually very easy to use, right? So think about this. If I told you that we had a problem, or the question was, find the equation, the linear equation of a line that passes through, and I'm going to make this up just so it actually is a pretty rough problem. Let's say like something like negative 257 over 11, comma, we'll say pi squared over 4, right? And it has the slope m equals to 42 over negative, we'll say 5, right? This would be an absolutely terrible problem to put to do in slope-intercept form because you'd have to go through, plug everything in, rearrange the equation so you can solve for b, and then plug that back into your new equation, right? Point-slope form, this is a, 5-second problem, right? Y minus y1 equals to the slope times x minus negative 257, so it's x plus 257 over 11. Done. Super fast problem, and this is going to be the way going forward into calculus and beyond, so we want to make sure that we're comfortable with point-slope form. Hope this helps.